Welcome to the Deep Dive. We're diving into something you might have seen in the news lately, the South Atlantic Anomaly. So, is this dent in Earth's magnetic field really something to worry about?
The South Atlantic Anomaly, or SAA for short, it's definitely got people talking. Basically, it's a region where the Earth's magnetic field is weaker. It stretches from South America all the way to Southwest Africa.
Hold on, wait. Weaker? Are you saying there's like a weak spot in our magnetic field, like a hole or something?
Well, not a hole exactly. It's more like, imagine a shield, right? Protecting the Earth from all that harmful radiation from the sun.
Okay, yeah.
The SAA is like a spot where the shield is a bit thinner.
Okay, but so what? The Earth is massive. How much radiation could actually get through a small, thin spot?
Well, it's not exactly tiny. I mean, we're talking millions of square miles this thing covers. And that weaker shield, it can cause some real problems for satellites and spacecraft.
Satellites? Seriously, I mean, those things are built to withstand all kinds of crazy space hazards.
True, but the charged particles from the sun, they can really mess with their electronics, cause glitches, data loss, sometimes even permanent damage.
Huh.
Yeah, some satellite operators actually have to shut down systems completely when they're passing through the SAA, just to be safe.
I never really thought about that. So what's causing this weak spot in the first place? Is it like some kind of alien weapon or what?
Not quite. The Earth's magnetic field, it's generated by all the movement of molten iron, deep down in the Earth's core.
Molten iron?
Yeah, like a giant dynamo. But sometimes that flow, it gets a little, disrupted.
Disrupted how? By what? Giant space magnets or something?
There are some theories. One idea is this massive, dense rock structure way down deep beneath Africa.
A rock?
Called the African Large Low Shear Velocity Province. Try saying that 3 times fast.
I think I'll pass.
It's thought that it might be interfering with the flow of all that molten iron. And that could be contributing to the SAA.
You're telling me a rock is messing with our planet's magnetic field? Seriously?
Yeah.
But is this rock going to be there forever?
The thing is, the SAA, it's always changing, drifting westward. Some scientists think it might even be splitting into 2 separate cells.
Splitting? What does that even mean? Like the Earth's going to have 2 magnetic fields?
No, it's not that drastic. Think of it more like one weaker area dividing into 2 smaller, weaker areas.
Okay. But is that dangerous? Does it mean the Earth's magnetic field is going to just vanish or something?
The Earth's magnetic field, it's actually flipped many times throughout history.
Flipped?
Yeah, but those reversals take a really long time to happen. Thousands, even millions of years.
So we're not all going to get fried by solar radiation tomorrow?
No, the SAA isn't a sign of an imminent pole flip. Scientists believe it's been around for millions of years. It's just a fascinating phenomenon that we're still learning about.
Well, I'll admit I'm still a little skeptical, but you definitely got me curious. What else is there to know about this whole South Atlantic Anomaly thing?
Well, one of the most interesting things is that the SAA might actually be connected to the Earth's auroras.
Wait, are you serious? You're saying this magnetic anomaly is somehow linked to the northern lights?
That's right. Changes in the SAA, they might actually influence where and how bright the auroras appear. It's just one example of how interconnected everything is on our planet.
Hold on. So a dent in the magnetic field, rogue rocks deep underground, and connections to the northern lights. This is way more complicated than I thought.
Oh, it definitely is. And there's still so much more to learn about the SAA. But by studying it, we can gain a much better understanding of our planet's magnetic field and the vital role it plays in all our lives.
All right, I'm ready for more. Lay it on me.
So this connection between the SAA and auroras, it is a pretty wild thought, right? I mean, this dent in our magnetic field could be creating some of the most beautiful light shows on Earth.
Okay, I admit that's pretty cool. But how does that even work? Is the weaker magnetic field like making the northern lights brighter or something?
Well, it's not quite that straightforward, but the SAA does seem to be playing a role in where those auroras show up and how intense they are. It all boils down to charged particles from the sun and how they interact with the Earth's magnetic field.
Charged particles. Okay, you're losing me. Are we talking about the same things that mess with satellites?
Exactly. Those charged particles, they're always hitting the Earth. But our magnetic field, it does a pretty good job of deflecting most of them, like a force field.
Right.
But in the SAA, where the field is weaker, well, some of those particles can actually get through.
So they're like little space invaders sneaking past our defenses.
You could say that. And when those particles slam into the Earth's atmosphere, they excite the atoms in the air, which makes them glow. And that's what creates those auroras.
Hold on. So the northern lights, They're caused by tiny space particles crashing into our atmosphere.
Pretty much. And the colors you see,
Yeah.
they depend on which atoms are getting excited. Like green, that's usually oxygen, while red and blue can come from nitrogen.
Wow, that's amazing. So if this SAA is always changing, does that mean the auroras could change too? Like, could we start seeing them in completely different places?
It's a real possibility. As the SAA drifts and potentially splits, it could totally change how those charged particles interact with the atmosphere. That could lead to, well, shifts in the auroral ovals, the regions where you typically see the auroras.
Wait, so you're saying the northern lights could, end up in Florida or something?
Well, it's unlikely they'd be visible that far south, but the auroral ovals could expand, shift around, making them visible in new locations. Imagine seeing the northern lights over, say, Paris or Rome.
Now, that would be epic. But all this talk of auroras aside, are there any other risks with this SAA thing, besides the satellite issues? Could it affect us directly here on Earth?
It's a good question. While the SAA doesn't pose a direct threat to people down here on the ground, there are some concerns for astronauts up in space.
Astronauts? What do you mean?
Well, think about the astronauts on the International Space Station. They're passing through the SAA multiple times every single day.
Really?
Even with all the shielding on the station, they're getting hit with higher levels of radiation in that region.
Wait, you're saying astronauts are getting bombarded with space radiation every time they fly through this SAA? That's got to be dangerous.
It's a risk, for sure. But it's something NASA takes very, very seriously. They monitor radiation levels constantly, and they have special protocols to keep the astronauts as safe as possible.
Like what? Do they wear lead suits or something?
Not lead suits, no. But there are special radiation-shielded areas on the station where the astronauts can hang out if needed, and they also try to limit their time outside the station when they're passing through the SAA.
So it's like they're playing a high-stakes game of hide-and-seek with space radiation.
You could say that. It's all about managing those risks and keeping those astronauts safe.
I get it. But what about animals? Don't some animals, use the Earth's magnetic field to navigate? Could the SAA mess with their sense of direction?
That's a great point. There's definitely evidence that certain animals, birds, sea turtles, they use the magnetic field to navigate. And yeah, some scientists think that the SAA could throw off their migration patterns.
So you're saying birds could end up lost and confused because of this thing? That's kind of sad.
It's a possibility, and it's something researchers are actively studying. We still have so much to learn about how animals sense and utilize the Earth's magnetic field.
This SAA, it's way more complicated than I thought. It's like this massive puzzle, all these interconnected parts.
You got it. It's a powerful reminder that our planet is incredibly complex and interconnected. And the more we understand about the SAA, the more we understand about the forces that shape our world.
Okay, I'm hooked. Tell me more.
One of the biggest mysteries about the SAA is its cause. I mean, we've talked about a few theories, but scientists are still trying to unravel exactly how the Earth's core, mantle, and magnetic field all interact.
So you're saying we don't really know why this dent is there in the first place?
We have ideas. But those exact mechanisms, well, they're still up for debate. It's a bit like trying to solve a giant invisible puzzle buried thousands of miles beneath our feet.
And how do scientists even study something that's happening so deep down? Do they have super X-ray vision or something?
Not X-ray vision, but they do have some amazing tools. They use satellites to measure the magnetic field from space and create incredibly sophisticated computer models to simulate everything that's happening in the Earth's core.
So they're basically building a virtual Earth to figure out what's going on inside the real one.
Exactly. And with each new observation, each simulation, they're getting closer to understanding the incredibly complex dynamics that create the SAA.
This is blowing my mind. I never realized the Earth's magnetic field was so, dynamic, constantly changing like this.
It's a good reminder that our planet, it's far from static. It's a living, breathing system with all these processes happening on a scale that's hard to even wrap your head around.
So we've talked about effects on satellites, astronauts, even animals. But what about the bigger picture? Does this SAA thing have any implications for the entire Earth?
Now that is a great question, and it's one that's got scientists really thinking. Some believe that the SAA might actually be a sign of a weakening magnetic field, and that could have some pretty significant implications for our planet's long-term future.
Hold on. You're saying the Earth's magnetic field could actually just disappear? Wouldn't that leave us totally exposed to all that dangerous radiation from space?
It's not something that's going to happen overnight, but it's definitely a possibility that scientists are watching very closely.
Okay, I'm officially worried now. What would even happen if the Earth lost its magnetic field? Would we all turn into, like, crispy critters?
Not quite that dramatic, but it would have some serious consequences. For one, our atmosphere, it would become much more vulnerable to the solar wind, and that could strip away some of its protective layers.
So no crispy critters, but maybe a thinner atmosphere. Doesn't sound great.
Not ideal. But remember, the Earth's magnetic field has weakened and reversed many times throughout history. Life on Earth, it's found a way to persist through these changes.
So you're saying we'll probably be okay?
We're a pretty resilient species, but it's a good reminder that we're part of a dynamic and ever-changing planet.
I'm starting to see that now. This whole conversation has been a real wake-up call. I came in thinking this SAA thing was just, I don't know, a minor curiosity, but it's turned into this incredible journey into the heart of our planet and beyond.
I'm glad you're finding it so insightful. The SAA, it's a fantastic example of just how amazing and complex the forces are that shape our world.
I'm ready for more.
Yeah.
What other secrets is this South Atlantic anomaly hiding? Okay, so we've covered satellites, astronauts, even confused birds, but what are scientists actually doing about this whole SAA thing? Are they just like sitting around watching it happen?
Oh, absolutely not. Scientists are keeping a close eye on the SAA. Using satellites, ground-based observatories, you name it. They're tracking its size, its shape, how it's moving.
Right.
And they're building some pretty incredible computer models to try and understand what's causing it and how it might change in the future.
So they're basically trying to stay one step ahead, just in case this SAA decides to throw us any more curveballs.
Exactly. The more data we can gather, the better we'll understand the SAA and its potential impact on, well, everything. Our planet, our technology, you name it.
Makes sense. But predicting the future, that's got to be tough, right?
Yeah.
I mean, even with all the fancy tech, can scientists really say what's going to happen to this thing?
Predicting the future of Earth's magnetic field, it's incredibly complex, so many factors involved. The movement of that molten iron in the core, solar activity, it all plays a role.
Yeah.
But scientists are definitely making progress.
So there's hope. We're not just like totally at the mercy of this magnetic anomaly.
Exactly. Science is all about understanding the world around us, right? So we can make smart decisions. The more we know about the SAA, the better prepared we'll be to deal with any challenges that might come up.
Okay, that makes me feel a little better. But let's say, hypothetically, this SAA keeps growing, weakening the magnetic field even more. What kind of challenges are we talking about here?
Well, we could start seeing more and more disruptions to satellites and other spacecraft. Imagine GPS systems going haywire, communication networks failing.
Uh-oh.
We could even see power grids going down because of solar storms.
Okay, now that sounds like something straight out of a disaster movie.
Right.
Are you saying this SAA could, like, take down our technology?
I wouldn't say it's an immediate threat, but it's something we need to take seriously. That's why scientists and engineers, they're working on ways to make our technology more resilient to those kinds of space weather events.
Resilient, like giving satellites some sort of magnetic shield or something?
It's a bit more complicated than that, but they're definitely developing new materials, new shielding systems, things that can better withstand radiation and all those charged particles.
Gotcha.
And they're also working on better space weather forecasting so we can see these problems coming and, protect our infrastructure.
So it's like a cosmic arms race. Well, we're always trying to stay ahead of these magnetic anomalies and space weather events.
I like that. Yeah, it's a constant challenge, really pushes the boundaries of science and engineering.
I'll admit it's a pretty cool challenge. But besides all the tech stuff, are there any other potential consequences? I mean, what about life on Earth? Could this actually affect us?
That's the big question, isn't it? Scientists are still trying to figure that out. Some believe that a weaker magnetic field, it could lead to higher radiation levels on the surface. And that could have implications for human health, the environment, the whole shebang.
Wait a minute. Are you saying we could all end up with, like, cosmic sunburns just by going outside?
Not quite that extreme, but there's definitely some concern about increased exposure to UV radiation, which, that can up the risk of skin cancer and other health problems.
Okay, I'm getting nervous again. Is there anything we can do to protect ourselves?
Well, the good news is we already have a lot of tools to help mitigate the risks of UV radiation. Sunscreen, protective clothing, being smart about sun exposure.
So it's kind of like the same advice we get for a day at the beach. Just slap on some sunscreen, wear a hat.
Exactly. Common sense goes a long way. And remember, our atmosphere, it provides a pretty good layer of protection from radiation.
Right, that does help. But what about those long-term effects? You mentioned the Earth's magnetic field. It's flipped before. What happened then? Did life just keep on trucking?
That's a question that has scientists scratching their heads. We know that during those magnetic flips, the field, it weakens a lot, gets pretty chaotic. The magnetic poles can wander, even switch places completely.
So compasses would be spinning in circles and birds would be flying all over the place.
Probably. And during that time, Earth would be much more vulnerable to all that solar radiation and those charged particles. But, and this is important, life on Earth, it's been through multiple magnetic field reversals and survived.
So we're pretty tough. We can handle a little magnetic flip-flop.
It certainly seems that way. Life, it finds a way. But it's a good reminder that we're all part of this dynamic, ever-changing planet.
This whole deep dive, it's really opened my eyes. I came in thinking the SAA was just, I don't know, some weird magnetic thing. But it's been this incredible journey into the heart of our planet and even beyond.
I'm thrilled to hear you say that. The SAA is a perfect example of all the amazing forces that shape our world.
So to wrap things up, what's the one thing you want our listeners to remember about the South Atlantic Anomaly?
Remember this. The SAA, it's a reminder that our planet is a dynamic, ever-changing system. And while it does present some challenges, it also offers incredible opportunities for scientific discovery, innovation, all of it. By studying the SAA and other magnetic phenomena, we can deepen our understanding of our planet and where we fit in the grand scheme of things.
Well put. It's been an amazing deep dive. And I'm walking away with a newfound appreciation for the Earth's magnetic field and the vital role it plays in all our lives. Thanks for joining us on this journey.
My pleasure. And to our listeners, keep exploring, keep asking questions, never stop learning about this incredible world we live in.